So, lab report. What's in a lab report? We've talked about some of the things. We've got an introduction. Background, I would argue, is introduction. Analysis. Where's my spacing on this? I would call analysis, I would call discussion. But yeah, it's fine to call it analysis also. What else do we have? We have an abstract. We have our results. Thank you. Our procedure or methods. What? So data hits a weird space. Data does not show up in a lab report. Results do. There's a difference between data and results. So when you do the INO lab, you ended with 0.5 grams. I don't know what you ended with, but let's say it was 0.5 grams. That is data. That doesn't show up in the results. What shows up in the results? Your percent yield. Okay? So results usually involves some thin layer or thin analysis associated with it. Thin processing might be the better word for it. Anything else? Yes.
Are sources cited?
You can go through, and since I'm kind of running out of space, I'll just say citations or cites. Let's call it just cites because that's all I got. Okay, that one's pretty thin. I don't really care that much about citations. We'll talk about how that's kind of not true. What's that? Yeah, conclusion. Okay. I have a colleague that goes through and calls this the IMRAD format for introduction, methods, results, analysis, and then done. Maybe I'm wrong. Maybe he doesn't call it an IMRAD. But anyways, that was kind of the structure that he's an English colleague that goes through and says that that's the science format. Okay, so what we need to do is make sure that we include all aspects behind this. As we go through and kind of navigate this, we'll address a couple different things. So first and foremost, how to go through and write. Okay, and you're putting this together, I would actually argue kind of against some of the stuff I've said in the past. I would probably argue that you need to start with your results. Okay, which is a little bit weird. Okay, but your results, depending on how your results come out and your passing kind of thoughts about what's going on with it. So it's results. It's not really discussion, but you're doing an interpretation. You're starting to do an analysis of it. You're not writing the analysis, but you're doing a little bit of an analysis. As you look at those results, you'll start to say, this is what my report is about. You have that about, that's a goal. So one of the most kind of critical pieces that you need within your whole report is to identify your goal. Now, every single one of these sections is written to support whatever that goal is. Okay? And if you're writing a bunch of words and you're like, I don't think this is relevant to the goal, you probably shouldn't be writing it. Okay? So it helps you to weed away the things that you don't need and helps you to highlight the things that you do need to address your goal. Kind of makes sense? Okay, so looking at your results and potentially looking at your data helps to kind of narrow the field a little bit to help you think through that. Okay? Once you have that goal in mind, now you can actually start setting up all the context that you would need to support why that goal is being obtained. That's now providing your supporting evidence that are not evidence necessarily, you're supporting documentation. That's now your background. So once you have the results, you now know your goal, now you can launch into writing your introduction. Okay? Once you have the introduction fleshed out, you could now start to say, well, because the introduction explained all the things that you thought were important, that were relevant for the goal, you could now go through, finalize your results a little bit, polish them up, and now you could move to your discussion. Because what does your discussion need to do? It needs to take all of your results and frame them, match them back to all the content you addressed in the introduction. The introduction says, oh, this is going to be a really important thing. I need to understand something about melting point. So here's what melting point is. Your discussion can now say, the melting point I got, my result, means this. Remember when I said that in the introduction? Look at me, I'm awesome. Okay? So the discussion is pulling all those little pieces together to say, fantastic, the goal was obtained for that result. So now you summarized all of your results in your discussion and what they meant. But each of those should have been mostly an independent thought. Okay? Result 1, result 2, result 3, result 4. Your conclusion now needs to take all of that analysis and put it all together into one bucket and say, this means overall it was successful. That's tying all those pieces together. That sounds an awful lot like a conclusion. Okay? At that point, we still have a couple sections left to write. We've got our procedure section and our abstract. I would argue at this point, you could probably do the abstract, and then you could save the procedure or method section for last. The procedure and method section is ultimately its own little thing. Okay? It's off in its own world just to report out what you did so that you can legally tell someone that you did it. And that's about it. Okay? So the procedure is kind of the nuts and bolts of what happened in the lab without going into extreme detail. So it's not critical to really any of those other individual steps. Kind of makes sense? Okay. So within our results, we would need to do some data analysis first. Conveniently, what did we do earlier today? We looked at some data to say what patterns were we starting to notice. We saw 3 different sets of IR. Okay, so what you now need to do is start grouping some of that data. If we saw 3 different sets of IR, let's start grouping those IRs. Do they all match the same technique? Cool, that's even better. Okay, we've got the NMR, and so you could start to group those concepts together. Okay, for your overall results, do you need to include all of, let's say there were 4 spectra that all looked the same. Do you need 4 IR spectra? No, you need 1. Okay, that one can now summarize all the others. You can go, well, there were a bunch of others that all had the same thing. If you really want to know what all the other ones look like, send me an email and I'll send it to you. Okay? But all you're trying to do is highlight the best of your work. Kind of makes sense? So our results, if we start with that, I have no idea how formatting this, by the way, is going to go. I had an idea in my head and it just kind of disappeared. So let's take a look at our results. Okay, this would be each piece of evidence, so all of our evidence. I don't even know how to spell evidence. Whatever, it's close enough. So let's assume the Ionone experiment. What was the evidence that we have to look at? We have the IR. We have the HNMR. Is that it? Ooh. We've got percent yield. Okay. So what you should start to go through and do is group those things to start to kind of come up with those categories. Okay. Those categories that we're going to be looking at would be each of our reaction conditions. We'll say A, B, C, D for our reaction conditions. Okay? And you could start to organize those thoughts. Once those things are now organized so that you can start to see them, you can now start to try and draw conclusions. Okay? Well, why were you allowed to draw those conclusions? So you're making a crude analysis here. Okay? All conditions achieved same IR. Or each condition achieved the same IR. I'm not quite sure how to write that. So everything that was A got the same IR. Everything that was B got the same IR. Does that make sense? All right, what does that mean? Okay, so each of the conditions are consistent. That's nice, but ultimately all that's telling you is that you now have something you can analyze.
IR is not going to help you differentiate.
Ooh, okay. So you could look at it and say, well, the IR is not going to help me differentiate if all of your IR look the same.
Yeah.
Do your IR look different? They did. So I would argue you should be able to differentiate them. How are you differentiating them? What are you looking for to allow you to differentiate? Say again? Bond types. Are all the bond types the same?
It's the intensity or the...
You could start talking about where the differences were. There was differences in intensity. There was difference in shifts. Okay? You're now trying to say, well, a difference in shift means something. Ooh. If you're going to say that, you'd better introduce that concept early on. So by highlighting what patterns you're seeing within the results, you can now start to say, I need to talk about that in the introduction. Because I want to be able to go through and say, I'm seeing the IR shift in this range. That shift means something. That meaning has to be framed in the introduction before you actually show the result. Okay? So you need to recognize, I got to talk a little bit about IR. In the IR, I need to address in my introduction IR shifts. Why does it shift? Resonance. So by starting to do this analysis, I got to put that in my introduction. Okay? I don't have to write it yet. I just have to identify that I need to talk about that information. Okay? Some people talked about intensity differences. So if you're going to say intensity differences, what do you need to talk about in introduction? IR intensity. What was the IR intensity due to? Dipoles. Okay? And before we get too excited and be like, oh, I got to write about all this, do you see it in the IR? You have to do that data analysis to see what's going on. You have to start to process what you're evaluating as different or the same within those systems. Okay? You've got HNMR. What's the HNMR going to tell you? Sure, it could go into unique hydrogens. Is that how we were using it? I know, that was like 2 hours ago.
We're just doing it here.
We did a qualitative analysis, and in that qualitative analysis, what did we decide?
It looks like,
It looks like
alpha
beta ionone, or it looks like alpha ionone, or it looks like a mixture. So your HNMR is really going to tell you what it looks like. Very, very, very qualitative. What would you need to set up in your introduction as far as your HNMR goes? Do you need to talk about multiplicity? No, you're not talking about multiplicity. How are you identifying what your product was? It looks like. What are you looking at? You could bring in the integration a little bit.
parts per minute, like little,
Where the peaks were showing up. You mean the chemical shift? You're using chemical shift to identify unique hydrogens. Those unique hydrogens have unique chemical shifts, which allows you to differentiate which one was alpha or beta. Okay? Are you going to talk about the area underneath the curve to ballpark estimate how much product you were getting? Yeah? If you're going to do that, what do you need to address in the introduction about HNMR? You'll need to talk about the integration. Okay? And we're not talking about essays. HNMR shows multiple different things. Chemical shift is relevant because it allows us to determine the identity of the chemical environment. Because there were 3 different products, they all have slightly different chemical shifts. We can use characteristic chemical shifts. What characteristic chemical shifts do you want to use? That would be a really good thing to point out in your introduction. We're going to look at these ranges. These are important ranges for you to keep your eye on, reader. Don't forget these ranges. This other stuff we don't care about, but look at this, because this is important. Okay? You can then move in, well, the integration is going to tell us how many hydrogens are there. We can use that to ballpark an estimate of how much of the alpha or beta are there. And we could acknowledge that it ain't going to be great because we're ballparking it. Because the lab tech that went through to determine the NMR was an idiot and didn't provide the proper data to zoom in on this range and since deleted everything because they were a moron. Don't do that. But, okay. Make sense? What else do we have as far as our results go?
Oh,
We have our percent yield. How do you calculate a percent yield? Your actual over your theoretical. The people doing this minus thing are calculating a percent error. We don't need a percent error. Okay, what we need is a percent yield. Okay, it's actual yield over theoretical. Your actual yield is straightforward. That's how much you actually obtained. That's the mass. What's the theoretical yield? It can't be the mass that you started with because the mass that you started with is a different substance to the mass that you ended with, which means creating that ratio isn't sensical. How do you get the theoretical yield? You go back to your Chem 151 notes and recognize that you have to deal with limiting reagent calculations and stoichiometry. Bruh, yeah. Okay, that's what you go through and do. What you'll find is this calculation is mostly 1-to-1, so it's going to be pretty close to the mass, starting mass. You still need to prove it, okay? Which is going to set us up for what we need to show within the results. Showing the IR, great. Showing the NMR, sure. Showing the percent yield. What part of the percent yield should you show? Should we just say the percent yield was 67 like it showed in the document? Ooh, so there's an idea. There's multiple trials, so you could probably average it. Do you think you need to show the limiting reagent stoichiometry? Yeah, but yeah, for only one reason. I don't trust that you know how to do it. Bruh. Sorry. Honesty is the best policy.
Is that how it is? I don't remember 151.
Exactly.
I mean, you literally just add up what's present in the molecule.
Okay. So when we talk about the organization for our results, an IR spectrum makes sense potentially for each of those individual compounds. The NMR also potentially makes sense for those. And you can pick your kind of highlighted ones, the ones that you think are relevant to talk about and address. Percent yield, you should show that as a calculation. The IR, the HNMR, and the percent yield are now at very least 3 different images. Each of those images should have a brief caption underneath describing what they're showing. So if you show me the IR, what the hell is it the IR of? Okay, do you know whether it's alpha, beta, or gamma, pseudo or ionone? No, so you can't tell me that. You could tell me it was the product of the reaction of pseudoionone with phosphoric acid and heat. Okay. That's now providing enough context that I know where that's coming from. Does that make sense? Okay. Same deal with the HNMR. When it comes to the percent yield, it's all going to be just math and calculations. Do you need to type that up? If you type it up, will it look pretty?
Mm-hmm.
Yeah. Do you need to type it up? How often have I cared about beauty? Just look at how I dress. I don't care. As long as it's written out and I can read it, you can handwrite it, put a picture in. That's fine. Okay, it does not need to be typed. Okay, but the calculation does need to get shown. Arguably, that's a picture, and you should provide a caption for it as well. Figure 3 shows the calculation for limiting reagent because my instructor is a dick. Man doesn't trust that I can't do these stupid calculations. Ramble, 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 ramble. Okay, that's fine. I'll put a little smiley face next to it. So everybody hates the stupid frowny faces. I'll put a little smiley face next to it. Give you all the points and move on. Okay. Do you think you could add something else to help a reader understand what you were trying to show? Like maybe a table that summarizes all of this information? What was the temperature what was the condition? What was the temperature? What was your yield? Okay. What was the ratio? Kind of like the table that was already in a lab that already did this experiment. Do you think maybe they had a decent idea on what should be summarized? Okay. So I would argue that's 4 major things that should show up in your results section. If we consider the size of those images, you're probably looking at, for your results section, I was estimating it last, whatever it was, Tuesday, and I don't think I did a very good job estimating it. You're probably in the 1 to 2 page range to cover those images. Okay, the IR and the NMR are big. Your calculations and then the table, depending on how you're formatting that, you can shrink that down, but you're probably looking at 1 to 2 pages just for your results. But by going through and looking at those results, you now start to have an idea of what your goal is. Your goal, you saw one of them produced pure beta-ionone. Maybe your goal is, I want to figure out the conditions to make beta-ionone. Done. Goal. You've got all of these conditions to now say, these ones suck, suck, suck. Awesome. Fantastic. Okay. So now when you go back and write your introduction, what do you need to address? We ready to delete?
Yeah.
Because we got 10 minutes. You need to take pictures faster. It's in the recording. If you wanted it, 23 minutes. Introduction. We now need to write our introduction. What needs to show up in that? When you went through and did your results, were there certain pieces that you needed to tie back into it? Okay. Make sure that information is there. And since you're fresh off the results, it probably makes sense to start summarizing that real quickly. Okay. You might be like, well, that order's going to suck. Hey, order isn't a draft. Order's the final thing. Focus on the draft first. Okay. So highlight those characteristics that you needed to analyze your results. That needs to show up. What else needs to show up? And so we want to be careful with this, because sometimes what will happen is people will go back. I don't know what I wrote, so. We got 10 minutes. I'm trying to go fast. Okay, so highlight those pieces that were necessary. This does not mean, tell me what your results are. This means, where are you going to look when we look at the results? It's the theoretical. I don't know what my results are. The introduction happened before I wrote the results, so I don't know what's going to happen, but I'm a genius and I know all the places that I need to look. Okay? That's the point of the introduction. Okay? So let's highlight those pieces, make sure they're nailed down. Okay? If we set our goal, we wanted to make pure beta ionone. Well, what other things could have been made in that synthesis? Alpha and gamma? Do you think maybe it's a good idea to explain how the beta ionone should be expected to form? You mean kind of like the mechanism? Yeah. The mechanism as an image and explained in text? It's going to take hours to upload these freaking videos. Okay. What else?
Tie it into a goal.
Yeah, your goal is pretty big here. You want to make sure that goal is real clear. Arguably, where should the goal appear in your introduction?
The beginning.
Right at the beginning. You want to make it real obvious to your reader that this is what I'm going to do. Let me wow you with all my content knowledge. You can then go through and do your mechanism. After a mechanism, you would now have products. And if you had theoretical products, what might you want to do? Explain how the results would show them. So if we were looking at an order, we might go 1, 2, 3. Right? We would start with our goal, then talk about the mechanism, then talk about the highlights. There's always an extra thing that gets inserted usually around the goal, so we'll call it 1B. That generally speaking, I don't care about, but some people do. Why do we care about ionone?
Perfume, smells good.
Okay? And I know none of you care, okay? Which is generally speaking why I tend to ignore this section, because really all you're writing is a bunch of nonsense that you don't actually believe with. Okay? So why should I waste my time reading stuff that doesn't show content knowledge and you don't care about? Okay? That tends to be why I'm a bit jaded in reading that. Okay? But it makes sense. You could go through and include that. Like I said, you can either spend time on it or not. It's not going to affect me or your grade. Make sense?
What kind of, what perspective do you measure? Like, it's first person?
Okay, that's a good argument. What kind of nouns, pronouns should you be going through and using this? Science is all an observation. You did nothing. You observed everything happen around you. You're like, but I poured. No, you didn't. You observed that your hands moved and chemicals were dispensed. You did nothing. Okay? Which means there are no personal pronouns. Okay? That has to stay out. That can make it a little bit trickier to deal with. If we look at an introduction, usually we're in present tense because we're talking about present or future tense because we're talking about something that is to come. So we haven't actually done it yet. Okay? Last things that we consider with an introduction, was there special glassware? Glassware or chemicals or techniques that were critical to obtaining the goal. Okay, that critical to the goal becomes the important part. Okay, I did the reaction in a round bottom flask. Was that critical that you did it in a round bottom flask or anything? Then no, don't tell me about that. Okay, that's not important enough for the introduction. Make sense? Okay, questions? Cool. I mean, take a picture. What comes after our introduction? Now we can go to the discussion. Within our discussion, how many results did we say we had?
3 or 4.
We had IR, we had HNMR, we had percent yield. There was another one, wasn't there? Ratio. Our ratio of alpha to beta, which is kind of coming from our HNMR. Okay? Each of those were a result, which means each of those needs a paragraph describing them. Okay? You've laid the groundwork in the introduction to say what that result was going to mean. So now what you can do almost is copy and paste your context from the introduction into the discussion, copy and paste your result into the discussion, and then prove that you can tie those two concepts together. You now have the discussion. Each of those is its own topic. So each of those is its own paragraph. You know what's exciting about the discussion? We're done. Do you want a picture?
In a minute.
What's the conclusion?
Just write about what you learned.
Do a little better than that.
Summarize.
Summarize all of your discussion points. Bring them all together to point to an overall success of your goal. Okay? Did you achieve the goal or did you not? That's what you really need to point out. The answer to that question, whether you did or did not, is not important to me. What's important is that you answer it and you provide evidence that you think supports it. I can disagree with you. It doesn't matter. Okay? What matters is that you're putting together your analysis behind it. Make sense? Now that you've written everything except the abstract and the procedure, you can double back to the abstract, write one sentence about every single one of those sections. Put those one sentences all together. Now you have roughly the abstract. Read through it and be like, God, this reads awful. Start cutting stuff out. Don't add stuff. Cut stuff out. Okay? Cut stuff out and build it so that it flows. You now have an abstract. What happens with the procedure section? So the procedure section has some important things that we'll note. Number one, it should be very, very easy for me to grade. Okay, because there's a couple big things that I look for. First and foremost, past, passive, verb tense. Remember, you're an observer. You observed this happening. Okay? My neighbor was abducted. Not aliens abducted him. Okay? So you need that was in there for pretty much everything. Okay? Past, passive, very concise. Concise is the hardest one to deal with, but it should be very, very short. No explanations. A recrystallization was done to purify. To purify is unnecessary. You're explaining why you did it. I don't care. You need to tell me what you did. That's it. Okay, so no explanations. We do need specific details. That one gets a little bit crazy because it's hard for people to interpret what specific details mean. How much material did you use? We measured out 1.5341 grams of material, whatever it was. Okay? That's the data that comes out. You want to tell me it changed colors? I don't care. Okay? You can include it, but you better include it really short. These chemicals were mixed, turned red. Cool. These chemicals were mixed, and the colors of the mixture swirled into an iridescent figure that looked reminiscent of the time that I was at the beach and I saw... Come on. Okay? Just kill it. It was already dead. Okay? Past, passive. Oh, no bullets. No bullet points, please. Complete sentences. Oh, I'm gonna have to try and edit that one. Complete sentences. Oh, you're such an idiot. Oh, Lord. Complete sentences. Yes, I'm lost. I'm fucking cooked. So we'll go ahead